That'll be fun, but soon here. I need the passport for one more day for identification purposes. Okay, hi everybody. This is the Utah Energy Code Talks. We're going to be discussing Energy Star 3.2 with Troy Pressler. First, let's thank our sponsors for this event. We have Dominion, which is now Enbridge Thermwise Energy program, and then the Rocky Mountain Power Watt Smart program, and then most importantly, Utah Office of Energy Development. Good on you guys. Great work. Thanks for doing it. Anyway, we got Troy Pressler over here. He's got a breadth of knowledge about all this stuff and is going to talk to us about all the fun stuff. Troy, do you want a big, long introduction? He's done energy rebates in the past. He apparently worked for a plastics company once upon a time, 20 years ago. All sorts of good stuff. And now he's a HERS rater and works for Building Science West. So I'll leave it to you from there.
Thank you, Kevin. So just a little housekeeping item. Got a mic here. If you have a question that's more than just a few words, just raise your hand. Kevin will get you the mic, and otherwise I'll just need to repeat back the question so the people online know what question I'm answering. So I'll set this here for you, Kevin, and actually just hand it to you here. Kevin will get that to you. So I didn't know who'd be in attendance today, and I'll say that I'm excited that there are some HERS raters here, and HVAC contractor, one builder, another builder. Tell me. So, see, all the best people are here for this. HERS raters, HVAC. It'd be fun if there was an insulation contractor here too, but it's not over yet. So we can all cross our fingers that we get an insulation contractor or two here. So, as Kevin mentioned, we are grateful for the organizations that make this possible. I think it's a great program. I've been surprised as I have been teaching Energy Code and Energy Star kind of throughout the state, really just from Cache Valley down through Utah County in the past, how there is in some cases, a gap in knowledge regarding things that I believe are fundamental to building good houses, good residential construction. I've been in rooms with 50 people many of whom were builders, none of whom even knew what a blower door test was. Not only had they not seen one, they had not heard of one. At that point, it had been state code for multiple years. So there are gaps out there still, and I think this is a great program. We're trying to close those gaps, and one of the ways is this program. I brought my glasses up so that I could see the keyboard so that I could hit the right button to forward the slides. Okay, so that's why I'll be taking these on and off. Okay, so this is a screenshot from, this is available up on the Utah Energy Code's website, which is a fantastic resource. I actually visit it quite often as a reference point. So if you're not familiar with the website, it is a wealth of what I think is valuable information, not just on Utah Energy Codes, which, let's be honest, Utah Energy Codes are kind of a unique animal at this point. We have a code that's a little bit different from any nationally published code. We've done our own thing, so we can't really go buy a copy of IACC 2021 and have that and build by that in Utah. Our codes are different. So this website is as good a place as any and better than most to try and get up-to-date and accurate information on the Utah Energy Codes. There are other resources there as well. There are There are blog posts and podcasts available, and the subjects do vary, but I think the common element to them is that it is regarding energy efficiency and energy codes in residential construction in the state of Utah. So, and it's utahenergycode.com. So I would recommend, if you haven't gone there, visit, and you'll get to read or listen to the brilliant Dr. Energy, who is kind of a composite of many people sharing their experience and their knowledge. So highly recommend the fantastic website. Okay, let's jump in. So I'm going to start off a little bit like why Energy Star as a program. There are quite a few above code certification programs for residential buildings. I work for a company called Building Science West. We do Energy Star certification. We will also do NGBS Green, LEED, and Enterprise Green Communities. I'm not saying that I like Energy Star because it's the only one up there that we can do. We can do all of them, or at least all of these. There are a lot of programs out there. But I do typically steer people towards Energy Star if I can, for a number of reasons. More and more so, especially in the multifamily world of residential building, people are looking for a variety of financing options, and specifically when you enter the low-income world. And so there are a couple of different programs through HUD that offer beneficial financing, and typically for new builds, Energy Star is one of the options to gain access to that preferential financing. There are other programs out there, but again, I like Energy Star. The Utah Housing Corp's, I wouldn't call it financing, tax credits, I believe it is, for low-income housing. That's the Utah State program. They also require Energy Star as an entry point into utilizing their programs for financing their projects. Energy Star certification, that can be used. You get points within, say, Enterprise Green Communities for Energy Star. It's one of the paths that you can use to achieve Enterprise Green Communities. And in some cases, you can make your application to Utah Housing Corp look better if you get additional points for doing Energy Star and Enterprise Green. And so having both of those together is helpful. And of course, the Energy Star helps with Enterprise Green. Chris Peterson.
Yes. So you say you do Enterprise Green. Do you guys actually administer the whole checklist? Or are you just doing the Energy Star portion?
Yeah, so the question is, we do Enterprise Green Communities. Do we do the whole checklist, or do we just do Chapter 5 of the checklist, which is the energy efficiency portion of it? Typically, we work with our customers. We will open the project on their website, do the pre-build, but we typically work with them on the checklist. And it's like, we'll do Chapter 5, and the reason Chris is asking this is the checklist covers things like, the one I like to use as an example that has nothing to do with actually building is, what is the proximity of the project to the nearest farmer's market, is one of the questions. We don't have any specific expertise in knowing the geographic locations of farmers markets in the state of Utah. So typically we ask and there are other things that are in the similar vein. public transit options that are near to the project as well. So typically the builder has that information far more than we do, and so we say, well, why don't you take a stab at that checklist, except for Chapter 5, populate it as much as you can, and then we just kind of partner up on getting that checklist completed. Again, other than Chapter 5, which is what we handle exclusively. So, is that what you've done as well, Chris? Or
Pretty much.
yeah. So, those of you online, I don't know if I mentioned this. I think we're fortunate that we have 3 HERS raters in the room, and they are HERS raters is the certification required to certify buildings and homes as Energy Star. So if there's quite a bit of back and forth, it's because I think we'll be able to have a good discussion with these gentlemen to help flesh out any questions that other people might have. So, speaking of another reason I like Energy Star, there's local oversight for most of the HERS raters in Utah, and that's not true for some other programs. Some programs, you put together a packet of information, the testing results, your inspection results, a folder full of photographs, and you send it off to a faceless person in another state, and then they have 30 days to let you know if your application has been accepted, or if they require any additional documentation, or if they have any concerns with what they've seen. With Energy Star, that's not the case. In our case, our local oversight is just down in Orem, and in this case, he's in the room today. And someone that I have known for, get this, Chris, it's been 18 years since I got into this. So, a gentleman that I've known for 18 years, and if any back and forth needs to happen, it can happen pretty quickly, and we're able to work closely together to work through any issues that might come up during the certification process. Also, there is a variety of certification costs. Some programs actually have pretty high fees for certifying into their program. I don't typically think that the government is a good solution for problems, but in this case, the fact that Energy Star is administered by the EPA, it does really allow us to keep the certification costs as low as possible, because I guess we're all paying a little bit of it through our taxes. Another thing that I really like about Energy Star is that, and this is probably as much a reflection about me and what interests me, is the program focus is on the building itself, and I like that. I guess I feel like, I just like buildings, and I think it's fun to focus on them. So, whether there's a farmer's market 1 block or 1 mile away, or a bike rack out in front, doesn't interest me as much as how well does this building function, how efficient is it, how livable, how durable, how comfortable. Those are the things that Energy Star focuses on. It's what I think is important in buildings, and so that is something that I've really liked. So that's why I think unless you've got some other compelling reason, Energy Star is a good place to start if you are considering a certification for buildings. And I may have actually inadvertently skipped over the most compelling reason, and that is there are quite generous tax credits from the federal government available for Energy Star certified homes. And that's kind of one thing that's driving actually us talking about Energy Star version 3.2 specifically today, and we'll discuss a little more why that is relevant. So, based on where we've gone so far, any questions? Okay, and certainly, I'm not one of those. Let's wait till the end to ask questions. Let's just get them out there, and we can hash them through as a group. So. All right. So we're going to focus on the building. We're going to build efficient, durable, comfortable, all that good stuff. And again, we do all these. Just Energy Star is I think, the best. There's one other program I should mention that I didn't put on the slide, and that is Zero Energy Ready. And that one is also a government-sponsored energy efficiency program. And welcome. Come on in. And I like that one as well. So Energy Star is by the EPA. Zero Energy Ready is by the DOE, Department of Energy. Now, the same guy actually created both programs. His name's Sam Rashkin. He was at EPA for many years, started the Energy Star New Homes program, shepherded that into program maturity, and then he moved over to DOE and created the Zero Energy Ready program. Energy Star is a prerequisite for Zero Energy Ready, and it just takes it a couple steps further. And I mentioned that there are tax credits available for Energy Star. There are also tax credits available for Zero Energy Ready. So if you're doing Energy Star, especially version 3.2, I think it's at least worth learning what the requirements are for Zero Energy Ready, and then you can make a determination whether or not you feel like it's a good value proposition for your organization. So we are doing some Zero Energy Ready certifications right now, and I think it's exciting stuff. I think they're really well built homes, and it's fun to be part of the project. So, all right. We had a few more people step in. Is it okay if I just ask kind of like what y'all do? It's just nice to know who my audience is and Okay, fantastic. Yeah. Heating and cooling? Both of you? All right, more HVAC folks in the house. Fantastic. Okay. So I'd mentioned a tax credit called the 45L. It's been around since 2006, and Chris, always feel free to correct me if I get something substantively wrong. In 06, the 45L tax credit was created, and what they did was they set, I'll call it proprietary energy efficiency standards, they being the federal government, for eligibility for that tax credit. And I will say that back in 06, I don't think too many homes got the tax credit. It was a pretty big stretch from where standard building was to what was required for that tax credit eligibility. Well, the federal government, typically they renewed that program on about an annual basis, and sometimes they'd wait till December and then renew it retroactively for the previous year, so people didn't even know if it would be available. But as codes and standards increased, the federal government didn't really up the requirements for the 45L. And so, quite honestly, in the past few years where codes had increased significantly, but that proprietary standard hadn't, the 45L became a lot more attainable. I think I couldn't speak nationally, but I know locally, started becoming used more often. There were quite a few restrictions on it. It was really the emphasis, I think, was meant for like, single family, 1, 2, 3 plexes. It was limited to just 3 stories or fewer. But that's where it was from '06 to 22. And did you do a lot of that, Chris? No. What about you, Steve? Okay.
And it's $2,500 now.
Oh, I know. This is, yeah. Oh, we're getting there. Yeah. Yeah. Okay. So
Oh, here we are.
here we are. Yeah. So, and one of the in my years of going to conferences and stuff in my job, I heard a lot of speeches by EPA regarding Energy Star and their branding, quite honestly, and they were really set that there would be just Energy Star, binary. Either you meet it or you don't. They really did not like let's say NGBS is doing, or LEED. If you certify something as LEED, you can be LEED, bronze, silver, gold, platinum. So there's a lot of flavors of LEED. There are different flavors of NGBS, but Energy Star always wanted there to be just either you're Energy Star or you're not. And they did a really good job of that for a long time. And that's unraveling a little bit. We'll get more into that. So the Inflation Reduction Act, which was passed, I want to say it was July 2022, I believe. It created, one really good thing it created was a program for the 45L tax credit that was for 10 years. So we're no longer updating the tax credit on an annual basis. So we know it's out there for 10 years, and that's a good thing. So people can plan appropriately. If you're a builder and you're trying to decide, is this worth it to me? The worst thing that would happen is you make plans to have your homes meet this standard, and then the next year, through a swipe of the pen by Congress, it goes away. So now we're guaranteed 10 years, which is a good thing. And then they changed the requirement. They said we need, instead of being what I call a government proprietary efficiency standard, it is now Energy Star. So that's a good thing. And it started with, I probably have another slide up that talks about when it started, which was homes that are closing January 1, 2023 is how it started. So if you wanted to plan for that, you would have had to plan several months in advance, because to certify as Energy Star, you've got to work throughout the building process. But and there are different versions of Energy Star out there, and historically, those have been in existence to reflect the different versions of energy code that different states in the United States have. So Utah is a slower adopter of energy efficiency codes than some other states, and so we had been on version 3.0 when other states had been on version 3.1, which is more demanding, requires higher level of efficiency. And then we had finally moved up to Energy Star version 3.1, and that's what was required for the 45L. And that's where we've been since January 1, 2023. Well, another change is coming. Now, to be eligible for the 45L, you need to be and this is for any home that closes January 1, 2025 or later, we need to be at Energy Star version 3.2. And that's what we're here to talk about is version 3.2. Just a note about, if you look up there, you'll see it says Energy Star 3.1 Rev 11, Energy Star version 3.1 Rev 12. So there are different versions of Energy Star and different revisions of Energy Star. And the revisions, those represent, typically it's a clarification of requirements. And typically, especially now that we're well into it, Rev 1 to Rev 2 were big changes back in the old days. But as we've gone down the line with revisions, typically they're pretty small changes and they don't necessarily represent additional requirements. Again, it's clarifications and oftentimes flexibility. Typically it's the EPA finding out that a requirement that they put in for the national program maybe the same requirement doesn't work well in Fairbanks, Alaska and Miami, Florida. Sometimes it can be tough to get a program that works for the entire country. So again, it's clarifications, but versions, yeah, Steve. Mic him up.
For Zero Energy Ready, though, it had to be 3.2 starting January 1st, 2024.
Yeah.
Okay, so it backed it up basically a year if you're going to go for both.
Yes. Yeah. So
3.2 and Zero Energy Ready too.
Yeah. Zero Energy Ready has already required version 3.2 as its baseline program, and that happened. What is it? We're in September now, 9 months ago. So, yeah.
And then maybe one other small point of clarification to a conversation I had with Chris earlier is I think 3.1 is still, you can still get certified Energy Star 3.1 in Utah. Oh,
yeah.
Am I stealing your thunder?
A little bit, yeah. Yeah. So I had mentioned how Energy Star loves the fact that there's just Energy Star or not Energy Star, that to keep their branding as simple as possible. And yeah, there have been different versions of it out there, but for any given state, there's only been one version of Energy Star in any given state at any given time until now. So you can still certify a home to Energy Star version 3.1. That is an official version of Energy Star. There are some, and my understanding is that will work for the HUD financing, the LIHTC programs. Version 3.1 will work for that for the time being. The one thing that it doesn't do is it does not give you eligibility for the 45L or that requirement satisfied for Zero Energy Ready. So 45L as it stands today, and I'll say this, if you're I know it doesn't actually take effect until January 1, but let's just be honest. Unless you've got a home that's almost ready to be done, it's going to need to be version 3.2 to be eligible for the 45L, because by the time you finish it, it's going to be next year. So 45L is no longer restricted to 3 stories or fewer. It's a more inclusive of larger residential projects. And it's now $2,500 instead of $2,000. Note that if you are doing 45Ls in, let's say, apartment buildings, multifamily construction, there are some other restrictions that have to be met before you're eligible for that $2,500. I don't know that I want to get into that today. It's payroll documentation, so it doesn't really have anything to do with actually building buildings. So, okay. How we doing, Steve? Am I doing a good job? Okay. Okay, sweet. All right. Now, this is where we get into just Energy Star. And I teach builders about Energy Star as part of what I do for a living. And if a builder says to me, what do I need to do to build Energy Star? If I read every word of every requirement to that builder, every footnote, first of all, they would tune out long before I got anywhere I needed to go. Second of all, it wouldn't stick. And so I have tried to figure out ways to help people understand the best way to know kind of where we need to go with Energy Star. And typically how I start is, and I'd be curious how the brain trust here on this row feels about this. I divide it up into two categories. Checklists, mandatory items, and energy efficiency. Energy Star has both of them. And the two pictures up there represent each of those. So one of those is the first of 7 pages of one of 5 checklists. Okay. Now, what would have been a really compelling presentation is if I just read checklists, huh? That'd be awesome. And the checklists are divided up into categories. There is duct quality installation, dwelling unit, mechanical ventilation. And so the checklist, those are mandatory. Now, in some cases where it's listing the requirements there, it will say or. You get some options in there, and this is a 7-page checklist. I could, off the top of my head, probably 2 or 3 of those pages are footnotes to the first few pages. So there are some ors in there, but typically if it's on this checklist, you need to do it. The other side represents the overall efficiency of the home, and I coined a term. It's copyrighted. I own it, so don't say it. These are called trade-offable. Okay, so I don't want you using my word. And what that means is Energy Star is less concerned specifically about how you reach the level of efficiency, and just concerned that you get there. Now, certainly there are better and worse ways of achieving a high level of efficiency in a home. Sometimes I use a stupid example of you could put R70 walls in and an 80% furnace, and maybe that would get you there. It'd be a really dumb way to do it. It might work. I've never tried to model it because it would be really dumb. But that's an extreme example of some flexibility. And actually, yeah, I think that, I don't know why you try it. It might work. Okay. I think we've actually kind of already covered this slide. Well, let me say a little bit about it, though. From the outset, Energy Star was designed to be about 15% more efficient than your current code. And that's why there were different versions of it in different states. There are some states, California, Oregon, Washington, Massachusetts, they've always been really progressive in their codes. And so they've had, in fact, sometimes they get their own special version of Energy Star that's beyond what the rest of the country gets just because their energy codes are so progressive. But by and large, it's designed to be about 15% more efficient. And if your code goes up, your version of Energy Star has to go up so that there's always that 10-15% delta. So if the state of Utah changed their way of thinking and we adopted California's Title 24 or something like that, our version of Energy Star would change in the following year, and it would change to be more I shouldn't say restrictive, require higher levels of efficiency to meet code. Okay. I think at this point, if you're going after the 45L tax credit and you are going after Energy Star version 3.2, I think that delta is well north of 15% at this point. It's probably 20-25%, it would be my guess. Again, I haven't done the math on it, but that's probably about where we're at. So there is a historically large gap between code minimum and Energy Star for 45Ls. Again, you can still do version 3.1. That would probably satisfy the requirement to build in Daybreak, which has always had an Energy Star requirement, but it doesn't get you everything that version 3.2 does. Okay. Trade-offable. I should put a little registered trademark there. No, the copyright C, okay? Okay. So one of the ways that Energy Star helps you know kind of where you need to go is they provide what they called a reference home. And you will get the reference home, and you will also get a target HERS index. And the target HERS index, I say you'll get. The way that a HERS rater will do Energy Star, and this is generally speaking, there is field work, and then there is office work. And and the field work, that involves doing inspections to look at levels and installation qualities of insulation and air barriers and flashings, and it also involves doing duct leakage testing and blower door testing and just overall inspections of the home, the equipment that was put in, verifying ventilation has been properly done, a lot of things. And when that's all done, you take all that information back and you input it into a software program. And that software program has a model of the house that's also been created in that software that tells us how big the house is, the direction that it's sitting, how many windows are in it, how big each window is, what side of the house that window is on, bedrooms, below grade, above grade, all that information is in there. And then the HERS rater will input their findings into that software program. And one of the things the software program will do is it will return a HERS score. And that HERS score, let me just jump back real quick. And okay, so it says the reference home of 100. There have been people that say, yeah, a HERS score of 100 is a code minimum home, and our homes are HERS 65, so ours are, 35% better than code. It's not true. If someone says that, they work in the marketing department. HERS 100 represents a code minimum home in 2006, is roughly what it is. That's when the HERS index was kind of created, and they just wanted to put a stake in the sand so that we always knew where that baseline is. So if you build a code minimum home in Utah right now and really go like as little as you can, you're probably, what do you think, 70s, 80s with a HERS score, do you think?
You're going off like the ERI path, you're 68.
Well, 68's the ERI path, but no one does that, let's be honest. if you do Res Check 2012, you could probably be in the 70s or maybe even 80s and meet code. But it's not 100 anymore. That was '06. Okay. So that's for some context. Now, a home at 0, that's a home that uses no energy. So of course, every home, so either it's a tent or it's a home that has solar panels on it. And typically, there's a certain point where it gets really, really expensive to make a home more efficient without solar panels or other on-site generation. And that's usually in the 40s. Do you guys agree with that? The 40s? At a certain point, it just gets really expensive to, take your walls, and I always use the walls because it's going to be ridiculous examples, to take your walls from R30 to R50 would get you a couple of points. It would cost a ton of money, and it wouldn't do you as much good as something that would, maybe throw in some solar panels on the roof or in the yard. So you get down to the 30s, 40s, and that's about as low as you can reasonably go without having to start putting on-site generation in. So that's maybe some context for you. Your worst built home's probably in the 70s, 80s. Your best built home is probably in your probably 40s. 30s is really hard to get. Probably in your 40s is kind of the reasonable range these days. My house is special. It's above 100. Yeah, my house was built in the 1880s, so we're going to give it some slack. But anyway, they're out there that go above 100, right here. Okay, so so the lists that come from EPA give you a reference home, and if you build a home to that level, or at least model it to that level, it should return a HERS score that is in the range for being compliant to Energy Star. Okay, Chris, how's this looking? You're making a face. Did I get something wrong?
No. Is this the reference for 3.2?
Yes, reference for 3.2.
That was my.
Yeah. Okay. Okay. So R60 in the attic, 20 plus 5. What that means is that you have in your wall, you have R20 between the studs, called cavity insulation, and then what that plus 5 means is that you've put 5 inches of additional insulation on top of the studs, typically called continuous insulation, and usually that happens these days in this state with rigid foam, those 4x8 sheets of pink or blue foam, and that's what 20 plus 5 means. So if you see one number plus another number, it's your cavity plus continuous. So, and then below grade, yeah, so you can do R15, which would be, see, this is why I wish we had an insulation contractor here. Typically I think of an R15 bat, I think of a high density bat for a 2x4 stud wall. That's R15 continuous though. And typically below grade in a basement that has not been framed out, you do get continuous insulation. It's just the big drape. There we go. That's the word. I had a coworker who called it the diaper, but drape is a better word. The drape, where it is continuous insulation, though it is stapled or nailed to the wall in places, and of course it's going to be lower in those places. So R19 below grade if you're just going between studs. So that would be if we've at least framed in the walls below grade, and you could also do 13 plus R5. So one thing, now you have to go down 4 feet with your slab edge insulation instead of 2 feet for version 3.2. Still R10. But, and this is something I'm glad we have some HERS raters here. Have any of y'all tried to get slab on grade homes to pass version 3.2? And have they? No. With all the pixie dust you throw at it, I have not seen a slab on grade home become eligible for 3.2. Now, I'm sure we could make it happen, but it would probably be really cost prohibitive. Like maybe our 23 plus 10 walls or something like that, might do it. And you would have to really go after the slab edge insulation, probably R15 or something. Yes, Steve.
I'm with Zero Energy Ready, we're within 1 or 2 points on slab on grades. I can get it to pass 3.2, but when you get to the Zero Energy Ready side, and we've been trying to figure it out.
Okay.
We're still trying. And it's amazing stuff that you have to do, like you say, pixie dust. It's pixie dust.
Yeah.
Try to get Zero Energy Ready. But 3.2, if you do some other things, we're getting them to pass, but just barely.
Yeah. Yeah. So it is difficult. Slab on grade, slab on grade is inherently less efficient than basements or crawl spaces in this climate zone anyway. So it's just kind of one strike against you. It just makes it that much more difficult. In the discussions that I have with builders, and we can talk about air sealing as well, you really have to have, you got to be pretty tight. I put 3 ACH or less. That's the reference home. So an ACH is an air change per hour. So it's a measurement of how much air leaks out of an enclosure under certain circumstances. I won't get too into it because it can get downright boring. But 3.5 is actually the code level for the state of Utah right now. But like everything else, the closer you get to 0, it gets progressively more and more difficult. So, going from 7 to 6 is a piece of cake. Going from 3 to 2 can be challenging. Going from 2 to 1 requires pixie dust, right? would require an incredible amount of effort. Window value is the U factor is 0.27, and typically, I don't know if y'all are finding this difficult to find 0.27 windows. I've talked to a number of window suppliers about getting there, and part of it depends on the window type. Some of the customers that we work with, they've been finding 0.25 U factor windows that are not cost prohibitive for them, and and if you can, I would say, if you can cost effectively find things that exceed these values, do it, because as Steve mentioned, some of his stuff is passing just barely, and so it's, if you can pad your stats a little bit for a reasonable cost, it's always good to have some headroom, so that when it comes down to the final thing, you're not finding out that, oops, I missed it by 1 point. You don't want to do that, because at the efficiency levels we're talking about, even 1 point can be tough to come by. So the solar heat gain is 0.30. Typically, if you're getting the window efficiencies on the U factor, and the way I think about this, I guess I come up with all these little ways to, maybe it's to help me better understand it or to help me better teach it. I think of the window U value as the window's ability to insulate in the wintertime. And the solar heat gain coefficient is the window's ability to insulate in the summertime. It's not quite that simple, but it helps me wrap my head around it, and sometimes people don't always want the science behind it. So that's how I think of it. And so typically, if your as your U values go down, your solar heat gain coefficient does too. There are exceptions to that always, but usually when one number goes down, the other one does. So in this climate zone, the U value is far more important than the solar heat gain coefficient. But typically you're not having a problem with one of the solar heat gain if your U factor is good. So water heaters, you had flexibility in 3.1. In 3.2, your water heater's got to be really top notch. If you're good with gas, tankless, comes with its challenges, but boy, modeling software really loves the efficiency of tankless hot water heaters. They get put in at like a 0.95 efficiency, and I think that kind of like how slab on grade's really tough to go. If you tried to throw in a standard hot water heater, it's not possible. You cannot hit Energy Star. Yeah, Carl. Oh, that's a good. What are some of the challenges of tankless hot water heaters? Let me say I've had a tankless in my terrible old house for like 10 or 15 years. And it's worked flawlessly for me. I'm knocking on wood. But the challenges with those are you're a lot better off if you have soft water in your house with one of them, because one of the ways they obtain their efficiency is with tight tolerances. The heat exchanger, there's got to be tight tolerances in there to get the surface area you need to have an efficient heat exchange. And when you have tight tolerances in water, mineral buildup causes problems real fast. So it really is helpful to have soft water, which I do. And also, every 6 months to a year, depending on whether or not you have soft water, you should perform maintenance on it. I'm a pretty handy guy, and so I went and bought a kit for doing that work, and it involves doing like a vinegar flush of your hot water heater. But it takes me like hour and a half to do it. And so you're supposed to do it every 6 months to a year. It's been longer than that for me. So, yeah. So challenges are they require maintenance. Now, again, I'm a handy guy. I actually, with the help of my neighbor, installed it. So I'm probably better equipped than most to deal with that. So if someone, it's their first house and they don't know what they're doing, I'm afraid it would never happen and they'd have a catastrophic failure eventually. So, and the worst thing is my teenagers can shower forever and not have the water get cold. So the pain is real. Okay. I'll be honest, all ducts and air handlers in conditioned space, is that mandatory or practical? I don't remember. Okay, so.
That's what the reference home.
Oh, yeah, that's reference, yeah. Yeah, so we're talking reference home. So the reference home has all the ductwork in conditioned space. So if you put your ductwork in an unconditioned attic, what you're doing there is that just means everything else on this list has to be ramped up a notch above of where it is. So again, these are trade-offable, copyrighted term, but go ahead, Steve.
Just backing up one thing is the Energy Star appliances. Okay, I found out that by putting in the pixie dust, that if you list Energy Star appliances, you can gain 2 points. If you they have to be installed.
Yeah.
Okay, but if you go to the reference, the HERS reference, which is if you don't install them, it goes to the HERS reference. You lose those 2 points.
Wow. Okay.
So if you're right there, you could put in Energy Star appliances, install Energy Star appliances, and you can gain 2 points: washer, dryer, refrigerator.
Dishwasher.
And dishwashers are always Energy Star.
Yeah.
So, but yeah, it's kind of like how many people in new houses supply the appliances.
Right. Right. Okay, so that's interesting. Now, typically, you get your dishwasher installed in new homes. I'm going to look over to you. Is that it typically for appliances in your new homes? Is it just a dishwasher?
For us, yeah.
Yeah, okay. Is that the same for you as well? Okay. So, and just know that as maybe you're figuring out at this point, if you're going for version 3.2, 2 points can be a lot, huge. So that's really good to know. So that's a strategy that you can use, is working with your builders to, and I don't know if it's just adding the refrigerator, because I know that's a big one, or the washer and dryer are needed too. But that'll be interesting to see how that affects things. Okay. So this is our trade-offable. Again, I feel like most of these things are right on the edge of getting so much more expensive. To do your walls, and even 20 plus 5 is remarkably more expensive than 23 or 21 or 19. So I feel like this is right on the edge, and so if you have to bump something up, it could get cost prohibitive. Okay. Oh, I guess I've kind of already gone through a lot of this. And Kevin, when do we want to?
That's what I was going to say. So I think we're going to set it up right now and then plan to break for lunch at 12. Does that sound good to people?
Okay. Okay. And certainly curious what our HERS raters, other HERS raters in the room have to say. I just kind of spitball this. Target HERS scores, and the HERS score needed to achieve Energy Star differs a little bit home to home. It's unique to that home. That's why I keep saying target HERS score. For version 3.1, it's kind of been in the 65 to 55 range. Again, lower is more efficient. Think golf, lower's better. Version 3.2, it dropped about 10, 55 to 45. And as I've mentioned, it's not linear. Going from 80 to 70, piece of cake. That's taking out your 80% furnace and putting in a 95. You just did it. But going from 50 to 40, because if you're at 50, you've already got your 95 furnace and your tankless hot water heater and your upgraded walls. And the low-hanging fruit is gone. And now it gets really difficult and expensive, or more so. So that's where, do you guys agree with that? 65 to 55 and then 55 to 45, has that been pretty good? Yeah. So that's about where we're at. Any questions on that? Yeah.
Back on the SEER rating, is that SEER 1 or SEER 2?
Oh, that's a great question. I think it's SEER 1, actually. Yeah. So Ryan just asked if it's SEER 1 or SEER 2. Ryan is an HVAC contractor, and SEER is seasonal energy efficiency ratio. It is the number that measures how energy efficient an air conditioning system is. And just to keep things complicated, as long as I've been in this business, there's just been SEER for residential AC as the efficiency metric. And a new one has been introduced. I don't know, was it the federal government who did, EPA who did it, or DOE? DOE introduced a new one. It's just called SEER 2. And I'm sure they had their reasoning for it. In fact, Ryan, do you want to tell us about SEER 2 for real quick? Here, let's-
SEER 1 versus SEER 2 basically is SEER versus SEER 1. Basically, SEER is a laboratory rating. SEER 1 is more of real world. Your static pressure is higher. SEER 2 is more real world. Your ratings are a little bit different, but if you tried to get a SEER, the old SEER rating actually on a project, you'd never accomplish it.
Okay,
Technically, you can't rate equipment in SEER 1 anymore.
right.
Correct.
So that should be revised to
Yeah.
reflect SEER 2.
Yeah. And these, I believe I downloaded and looked at the most recent documents from EPA. And I don't remember it saying specifically SEER 2. So that doesn't necessarily mean I didn't mess up, but okay, there we go. The software converts it. So, yeah. And you know, I've talked about how strict this is and how every point counts, and it does. In Utah, less so in Washington County, but in Utah, the efficiency of your heating equipment is far more important than the efficiency of your cooling equipment. If you were going to say, I've got an extra $1,000 to upgrade my HVAC, where should I put it? You know, I'd make sure your furnace is as good as it could be before I went after the AC side of things. In Utah, in Miami, that would be different. There is no heating in Miami, I don't think, so it's maybe a bad example. But we do about 6 times as much heating as we do cooling in Utah on an annual basis. So it's important to do the best you can on the heating side, especially. As evidenced by the fact that Energy Star pretty much specifies federal minimum as the requirement for cooling efficiency in this climate zone. This is climate zone 5 here, go over the mountain to Park City, climate zone 6. It's even less important there. Okay. Mandatory checklists. So these are all the ones that I said are well, of course they're mandatory. It's implicit in the name. It's explicit in the name. These are checklists that need to be completed for the home to be certified as Energy Star. Some of them are completed by a HERS rater. Some can be completed by the builder. Some by an HVAC designer. Some by the HVAC installer. And there is some more flexibility in how the HVAC side of things happens now than previously. And we can get into that a little bit. Let's start with, let's see here. Where should we start? Well, I don't even know how deeply we want to go into the checklists themselves because it's a lot. Multiple pages for each one, and there's multiple checklists. This one is the National Rater Field Checklist. So this is one that the HERS rater completes when they do their inspections on the home, and some of the things that they're looking at. So let's see here, reduced thermal bridging. So there's a requirement in Energy Star. Thermal bridging is when heat typically passes through a stud in the wall, because wood is about R1 per inch. So in a 2x6 wall, your stud cavity that has the insulation in it is, I'd say, minimally rated at R19 or maybe R23, depending on the insulation that's in there. But that stud is between R5 and R6. So call that a thermal bridge. The heat's going to go through that stud, traveling either direction depending on the season, which way it's going. Many years ago, when I was first in this business, I worked for the Rocky Mountain Power Watt Smart New Homes program. So long ago that it wasn't even called Watt Smart back then, I don't think. And I thought that, and still do, think that thermal imaging cameras are about the coolest thing around. Anyone that was young when they saw Predator for the first time knows that thermal imaging looks cool. And I wanted a thermal imaging camera so that I could do inspections on homes. And they're still really expensive, but back then the one that I thought would be cool was like $5,000. And my boss said, well, you can come up with $5,000, you can get one. And guess what? I did. I found a contract and I got someone to pay the program $5,000 and bought a thermal imaging camera. And I was so excited to use it. And I was convinced, actually, that I would go do all these thermal imaging inspections on homes in the Rocky Mountain Power program, that I was going to find all this misaligned insulation. And so I went and I did tons of thermal inspections on homes. And what I found was actually very little misaligned insulation, which would result in, if it's a really hot day outside and you looked at the thermal imaging camera, there'd be a hot spot showing up on the sheetrock in the wall on the camera. I thought I was going to find that. I was wrong. The insulation, by and large, at least from the thermal camera standpoint, was installed really quite well. What I was surprised to find is how prevalent the thermal bridging was. That when I would look at a wall, I could see every stud in the wall. It would show up as a hot spot on the sheetrock because of the heat. Again, actually, it would have been showing up as cold spots. I did it in the wintertime. So it'd show up as a cold spot, and I could even see all of the screws holding the sheetrock to the studs, because being steel, those are going to transfer energy even better than the wood would. So in extreme examples, it almost looked like X-ray vision for the wall. It wasn't, of course. It was just reflecting the difference in the surface temperatures. But the way the walls are constructed, the heat or the cold, however you want to look at it, comes right through. The most dramatic is the headers, because typically those are solid wood, and the worst are the top corners. And typically that's because at the time very few people were doing raised heel trusses, so we weren't getting full depth insulation. So that's what I learned with my little thermal camera experiment. I also learned that doing thermal inspections on lots and lots of homes gets really boring really quickly. But that exercise taught me the importance of reduced thermal bridging. So Energy Star goes after that issue with a couple of ways. First of all, you can just put up continuous rigid insulation. I keep saying rigid, it doesn't have to be rigid. Continuous insulation all around your house. And that's going to take your, I'll just assume 1 inch. That's going to take your, that area, and typically the solid wood in a wall is over 20% of the wall when you add in the window openings and the door openings and the headers, and of course all the studs. King studs, jack studs, cripples. So it's not insignificant to have 20% of your wall rated at about R5 instead of R19 or R23. So putting up just an inch of rigid insulation is going to double that 20% of your wall that's only at R5. So it's significant. It's also not common practice in Utah right now. And what that means is it's really expensive. And I think you get not a lot of contractors who are just kind of scared of it. And I know one guy who's done it on his house. He actually ended up having to do part of the work himself. I think partly because his contractors were just a little gun shy of how to do it correctly. So it's a great way to go if you can find the right contractor and get them to do it at a good price. But this is one of the ors. Okay, so you can put up rigid exterior insulation around your home, or you can minimize the thermal bridging by doing advanced framing, which is basically minimizing the number of studs in the wall. So California corners, ladder block wall intersections. Yeah.
Utilizing 2x6s, working that way, using less lumber overall.
Using less lumber overall, yeah. 2x6. Yeah, we're except for Washington County, I don't see much 2x4 construction in Utah anymore. Do you guys? Do you?
There's some buildings that still do 2x4.
Okay. Not too many of our customers do 2x4 anymore. So it's, and I will say that typically those of us in the energy efficiency business will say, yeah, it typically costs more to build a more energy efficient home, but it's going to pay you back in lots of different ways. Advanced framing and reduced thermal bridging is the only place where that's not true. It actually can cost less. In fact, I've got, let me just find this picture. There we go. Yeah. That's one I took. I was walking the project with the VP of construction, and when we stumbled upon that, he rolled his eyes, and I think some curse words may have flown out of his mouth. Something about our framers seem to think that lumber is free. Mind you, this is a 2-story building. If this was 6 stories, I might get it, but this is 2-story. And that's a perfect example of the opposite of what we're talking about. Because what we're talking about is using just the fewest number of studs that is legal and possible. And typically, if you've got engineers' requirements allowing, saying you need to use this much lumber for the structural integrity of the home in a certain place, Energy Star is going to respect that. We're not asking you to. Well, obviously you wouldn't be able to anyway. But if an engineer says that's how many studs you need, fine, that's how many you get to use. But oftentimes it's the framers who are making those decisions and not the engineers. Now, I've said a good way to reduce excessive framing is to take away people's pneumatic nailers, and they're only going to get the studs that you actually need in there. But you also wouldn't be able to hire a framing crew. So that's the HERS Raider. I'm trying to decide if we keep going or if we just break.
Yeah, what do you think? 12?
Let's break. It's noon.
Who's hungry?
Who's hungry? Yeah, I've always said you never want to be the person that's standing between anyone and their lunch.
Yeah, but we
So-
listen a lot better after.
Yeah. Yeah, hopefully there's a lot of turkey there, so everyone's going to be top game after lunch. All right. Okay. Welcome back, everyone. All right, let's see. We were talking about checklists. But I want to circle back. Is Kevin, let's see, there were a couple of things that we talked about at lunch that I wanted to, yeah, which slide was that in?
I saw at least the minimum trade-offs.
Trade-offable, okay. Yeah, one thing I just wanted to touch base on. Here we go. The water heater. I wrote water heater gas, 0.9 UEF, electric 2.2 UEF. And one thing that I've seen a little too often is with water heaters specifically is people will switch from gas to electric water heaters as a step to make their building more efficient. It certainly can do that, but it can also go the other direction real fast. So with gas water heaters, there is a variety of efficiencies that you can get. You can get the standard federal minimum efficiency gas water heater that's got B vent, which is a double wall metal venting that goes out the top and that has to go out the roof. It has to be vented vertically. You can step up in efficiency from that and get them that have PVC pipe that is power vented out, and that can be vented out horizontally. That's more efficient because the exhaust gas coming out is cool enough that it doesn't melt the PVC. Those are sometimes called a one-pipe water heater. At least that's what I've called them. It's got one piece of PVC. It's still drawing the combustion air from the room that it's in. And then you go to a two-pipe where it's bringing in the combustion air from the outside through a piece of PVC and venting out the the exhaust air through another piece of PVC. And those are both still have tanks. And then typically the most efficient gas is the tankless. So there's a scale, there's a variety. With electric, and let me go back to gas, and there might not be a huge gap in efficiency between any two of these water heater types. They're always just going up, and again, 4 or 5 different types. With electricity, you've got to be careful because there are 2 main categories of electric water heaters. And one of them is just a resistance water heater. So it's just heating up the water with a resistance element. It's like the burner on an old electric stove. It's high resistance. You put a current to it, it gets warm. That's it. And they're simple. They're low cost to purchase, and they are remarkably inefficient and expensive to operate. Now, there's a challenge with them, though, because if you look at the efficiency on paper of them, it's really high because what it's measuring is how much of the electricity that goes into that thing is being used to heat the water versus being wasted someplace else. And according to that number, it's really high. It might be in the 90s. Is it even higher than like mid 90s, Chris? Somewhere up there. But that can be really deceiving because it's also the most expensive way there is to heat water domestically. Unless you wanted to burn dollar bills to heat your water. That'd be more expensive. Now, there's another category of water heaters. They're called heat pump water heaters. And they come with their own set of challenges as well. But they're typically about 300% more efficient than the resistance. Not 30, 300. So there's a huge gap between resistance water heaters and heat pump water heaters, and there's really nothing in between that massive gap. So if you are looking at doing all electric or even just electric water heaters, and you're concerned about efficiency, you're thinking about Energy Star 3.2, it has to be a heat pump water heater. 100%. A resistance water heater will kick you out of the program and there's no way you can get back in. So just wanted to, and there's actually another type of You can even do electric tankless water heaters. I run into those a few times. And just be really careful. There's a big difference between a gas tankless and electric tankless. Electric tankless, they are somewhat small. If you get a whole home application, you need either 60 or 80 amps of service just to take care of it, because they use about 25 to 30,000 watts of electricity to heat the water. So it is not an efficient way to go. Electric tankless has its place. Whole home applications and efficiency typically don't go together. People just misunderstand. They hear tankless, they think efficient. They hear electric, they think efficient. They think electric tankless must be efficient. Not really. Okay, so if you're going to go electric, it's got to be heat pump technology. How do we do, Kevin?
I think you did great.
Okay, thank you. and one challenge is I find people going to not for version 3.2, because this is all pretty new stuff, but in the past people have gone from gas to electric just on the water heater, so that they can eliminate the combustion air duct, and they're doing it to get their homes tighter. What they don't know is that they're costing their homeowners quite a bit additional money for their water heating. It's expensive. So I think the lowest cost way to for the end user to heat water residentially typically is a tankless gas hot water heater. And typically those are over 95% efficient. So let's see. Hit that. Okay. Water management checklist. Let's cover that one. That is the checklist here that the builder is allowed to complete. Everything else has to be completed by someone else. The reason the EPA allows that is some of the items on the water management checklist are visible at times when a HERS rater may not be on site. And so they're really just trying to keep the HERS rater from having to come on site 5 times for every home, which could become cost prohibitive. It's just expensive. Every home visit costs money. And so the builder is allowed to complete that one themselves. It's a really important checklist, though. I mean, what's the cause, the number one cause of failures in homes? Water. It's most of the time it's bulk water too. We'll talk about ventilation and vapor and condensation, and though that can certainly be problematic, but typically it's bulk water intrusion. So just because the builder is allowed to fill it out does not mean that the flashings don't need to be done correctly and things like that. I was so neurotic. We actually put pavers in around our chicken coop last year, and I was telling my wife, I'm like, okay, we've got to be sloping away from the coop, at least a quarter inch per foot, just to make sure we don't have any problems with our chicken coop foundation. So it's important everywhere. Always direct water away from the building, and the builder can take care of that one. Okay, HVAC design report. So from a 30,000 foot point of view, what Energy Star is asking you to do with regards to HVAC, if we wanted to break it down to its simplest terms, is do it right. But to give a little more detail, design your system with accurate information based on the home plans, and then you're gonna derive your loads. It's called a manual J, and garbage in, garbage out. It's only as good as the information you put into it. So an accurate manual J that's going to determine the sizing of the equipment, and then design the entire system to function correctly, and that's going to mean designing your duct system so that you get the correct amount of airflow. It's been a while since I've been aware of any study regarding this, but and maybe the state of Utah has improved dramatically since I was last involved with it. But the last time I was involved with it, the airflow per ton of cooling in the state of Utah is typically woefully inadequate. Is that still true? Still true. Okay. So, and what I mean by that, for a reason that I won't explain, the size of cooling equipment is measured in tons. And typically in residential systems, unless this has changed, the smallest system you see is 1.5 tons. The biggest is about 5. You need more than that, you add systems. And you need a certain amount of airflow, measured in cubic feet per minute, for every ton of cooling that you have, because cooling requires a lot of airflow to function correctly. And one of the biggest problems in residential HVAC installation is either oversized equipment and or undersized duct systems, or at least duct systems that aren't designed and installed well enough to get the airflow you need. And so what Energy Star is asking you to do is to size the system correctly, install a duct system that is correctly sized, so big enough, and you've got the correct fittings, hopefully even some radius turns in there so that the air can flow more evenly and not have more excessive static pressure. Static pressure goes up, airflow goes down, so you need to have a duct system that is designed to function correctly for that home, for that HVAC system, for that furnace and air conditioner. And then of course, the refrigerant charge needs to be appropriate. Sounds simple enough, and you would think that professionals would get it right most of the time. There are some HVAC contractors that do a fantastic job, that gain all the education they can, and they and their guys have additional certifications that aren't required even by code and by regulation. They do it so that they can be the best they can. There are some that don't, and the problem is that the inadequacies in those systems are not necessarily evident on day one, and so they don't necessarily get a call back right away, and so it's allowed to proliferate. So Energy Star is asking you to address all those things. So you've got your HVAC design report that asks you to document how the system was designed and your inputs, and making sure that it was done correctly, that it was designed correctly. And you have your HVAC commissioning checklist. Now, commissioning is something that is common in commercial buildings. To have something commissioned, you have to typically you hire a company to do the commissioning on your heating and cooling system. In residential construction, single-family detached homes, not something that really happens. The company that installs it makes sure it's working right and then calls it good. But what the HVAC commissioning checklist is asking you to do is not just turn it on and make sure it blows cold or blows hot, but it's actually asking you to take measurements and make sure that everything is within the design parameters of the equipment and that it is functioning as it was designed. So, how'd I do, Ryan?
90% of the designs are flawed.
Okay. So the comment was 90% of the systems the designs are flawed in the state of Utah. I've been trying to be nice because my friend Ryan here is an HVAC contractor, and I don't want to think that I'm dissing on his industry. Okay. So I don't know if the HERS Raiders here in the front row, if you have any comments on HVAC commissioning checklists, HVAC design reports. Steve.
What I see when you compare the checklist to the actual house, okay, the design report to the actual house, and you're supposed to sign off on it under Raider design checklist, okay, but you don't correct the design as a Raider. You only say, okay, they did this, they did this, they did this, but some of the things in there that I always see is like windows and doors and insulation levels and envelope leakage levels, in other words, blower door levels, and all of this stuff is not right. And in a way, you get they're going to do the manuals. Well, how do they know what windows got installed? And they did the manuals 6 months earlier to get the permit. And you don't know what got put in.
Yeah.
The guy that's designing it, okay? He doesn't know what insulation levels they've done because they may have changed. Maybe they told him this and that's not, or he assumed it. That's my problem. That's what I see is the biggest problem with the design. Because the software should pretty much take care of how much flow you need here, how many CFM here, how many CFM there, and so forth, what your pipe diameter is and all this kind of stuff.
Yeah.
But I think the input of the house is the problem.
Okay. And I would agree with that. I think that I think what drives it partially is just what you've said, is not having the data at hand at the time that you're doing the manual J. And so a manual J is a, I was going to say it's a software program. Now it's a software program. It used to be done by hand. There are equations for determining how much cooling a home needs, room by room, space by space. And it requires you to input the efficiency of the windows, the insulation, the assumed air leakage of the home. And in absence of those things, I think HVAC contractors are afraid of, it's July 26th or something like that, and it's 103 degrees outside. The last thing they want is a phone call from a system that they installed in February saying, it's 87 degrees in my house, it won't get any colder, get out here and fix it. Is that fair, Ryan? That's
There's some fear of that.
Some.
Because people don't understand.
Yeah.
Really make a decision.
Yeah. And so people that don't understand, they're just, I'm just going to put in a little bit bigger system, and I'm going to and by doing that, I'm going to make sure that I don't get that phone call in late July with a comfort issue. And what they may not understand is that you create as many problems, you create more problems by oversizing your equipment as you do solving them. And so you end up with oversized equipment that doesn't function correctly. And it doesn't just hurt your efficiency, it hurts your comfort and durability of equipment. It hurts lots of things. But I think it's kind of fear-driven. Water management. All right, we ready to move on to the next slide? Okay. Well, there we go. That's one of our workers there. Former. Performing a duct leakage test, and we even had him break out. You can see down there in the corner in front of the duct blaster is our theatrical smoke machine. And you only do that typically because the theatrical smoke actually kind of gums up your equipment a little bit. You only use that when you really need to. And typically, you only smoke your systems when you're doing show and tell with people. sometimes it's a recalcitrant HVAC contractor who believes their duct system actually doesn't leak, and you have to show them with smoke. But what we do is we cover up the registers, and then that black thing is a fan, and we've got call it the Jiffy Pop tube. We pressurize the duct system to 25 pascals, which is, I think people sometimes think when we're doing a duct test that it's a ridiculous amount of pressure that we're putting in there to induce the leakage. It's really not. The fan's just noisy, so it seems like it. It's, okay, that's 1/10 of an inch of water column, isn't it? 25? Yeah. So, HVAC systems in certain places, do you ever get up to an inch of water column, Ryan?
No, not in residential.
What, half inch though?
Ductwork, yeah, no more than half inch.
Okay. Yeah, so,
And normally only 0.55 is about max.
okay.
Residentially.
So the amount of pressure that we are inducing for this test is actually pressures that are experienced in duct systems during operation. So even though it's a noisy fan, I've just been criticized saying it's not fair to tell me my duct system leaks when you're squeezing it so hard. I'm like, actually we're not. We're just making a lot of noise while we squeeze it a little bit. So we have what the gentleman in the photo's name is Cyrus. What he's, I'm sure he's just posing, trying to look really deliberate while he's doing it. But that's a little pressure gauge. It's called a manometer, but it's basically a pressure gauge and kind of a little handheld computer. And so what we're doing is we're measuring the pressure inside the duct system and the pressure outside the duct system. And then that fan is also communicating with the little handheld computer, and so that we know how much air is moving through the fan. And so we just adjust the fan until the pressure inside the duct system is a steady 25 pascals, or about 1/10 of an inch of water column, higher than the pressure outside of the duct system. And then we just look at how much air it takes to maintain that constant pressure differential, and that's how we know how much air is leaking out of that duct system at that pressure. And this is one of the tests that HERS raters will perform. It is actually part of Utah code to test duct systems if at least part, and definitely if all of that duct system is outside of conditioned space. And typically in Utah, that means if you've got ducts in an attic. If you have a system in an attic, then that automatically means that duct system needs to be tested for code as well. And what we do is we calculate how many square feet of floor space that system is serving. So it's easy if there's only one system in the house. It's the square footage of the home. And then you're allowed a certain amount of cubic feet per minute per 100 square feet of conditioned floor area. We say percent, but it's not really percent. It's just, and it depends on how many returns there are in the system. But that is how a duct leakage test happens. And kind of the thinking behind it is, I've had it argued to me lots of times that who cares how much the ducts are leaking if they're all in conditioned space? And fair enough, but if you take that to its logical extreme, if that's true, why put duct system on at all? We're trying to get the conditioned air to a certain place in a certain amount to heat or cool a certain size space. And when you don't do that, you have comfort issues, but you can also get, and this comfort issues are usually what drive things, but you can also get pressure differentials in the home. So especially if you have a return air side duct that is leaky, because those are under negative pressure. And so they will just be sucking air from wherever they're leaking. And so you could be putting a room in your house under negative pressure and sucking air from who knows where. The worst case probably would be a room adjacent to a dirty garage where you might have gas cans or paint cans. And the return air side could be sucking air from that garage into your duct system and then distributing it out to your home. Now, that's probably worst case. Is there a worse scenario than that? That's probably it. Yeah, sucking nasty fumes into your house. But having pressure differentials in your home is room to room can be bad. One could be positive, one could be negative, depending on how the ducts are leaking. So let's just seal them up so the air is going where it's supposed to in the amount that it's supposed to. And then your home's more comfortable, lasts longer, safer, all those good things. Yeah.
Can a lower door test help you determine different pressures in rooms?
You meant duct leakage test, I think. And just a duct leakage test does not tell you where it's leaking from. You have to, with the equipment that we have, you can definitely figure all that out. And you're also not supposed to have any two spaces more than 3 pascals different in pressure. So you do test the rooms to see if there are pressure differentials there, and they all should be close to each other. So Energy Star also asks you to provide a return air path from the, let's say, a bedroom, and you've got just a central return rather than a return in every room, which is not uncommon. Energy Star doesn't say that you need to have a return air duct in every room, but you have to provide a way for that air to get back to the furnace. And there's a variety of ways you can do it. You can use a return air duct. You can use jump ducts. You can, I don't think this is ideal, but you can make sure the undercut in the door is high enough to allow that airflow. But you have to allow a way for that air to get back. Otherwise, when the door's closed on that room, the pressure in that room will just go up, and you don't get the airflow you need, and it reduces airflow throughout the whole system. So you can figure those things out. I love this one. Unfortunately, I took that picture. Anyone want to comment on what's wrong with this? You're laughing in the back row. You know what's wrong. So it's actually a nice ventilation fan that was installed there. So a little quick lesson. Our HVAC guys live and die by this stuff. But there is something called static pressure in a duct, and there's friction when an air is moving through a duct, and that friction will cause pressure to build up in it. Sometimes it's nominal, sometimes it's significant, and flexible duct has higher static pressure because it's rough and it's harder for the air to get through it. And as you could guess, it's harder for air to go around corners than it is to go in a straight line. And so because of that, to help HVAC designers understand how best to design a system, there's something called equivalent length. And so a 90-degree corner, even if it's kind of rounded off, has the same static pressure or equivalent length as like 20 feet of straight duct. So corners are really hurt things. The worst case I've seen is, a 90-degree bend or even a T-bend that comes up out of a furnace and then splits off two ways. That might have 120 feet of equivalent length. It's really hard to have a system that works well. And so what happens in those situations is the airflow just goes down and down and down. So this fan is probably a 100 CFM fan, as rated by the manufacturer. But the fact that duct comes out of it, and then there's a hard bend right, within 6-9 inches of it, that just reduced the airflow of that thing by a lot. And then we've got, that's even more than 180. That's probably a 200-degree bend in flex duct. That's probably the equivalent of running a straight duct 60 or 70 feet. And I don't even remember how far that actually had to go to get outside the house. Unfortunately, that 100 CFM fan, I didn't test it. I was doing something else there. Is probably moving 20 or 30 CFM, would be my guess. Maybe. Does that pass code? Depends. Well, actually, it doesn't depend on the city. We have a state code in Utah. Whether.
Code now that it doesn't. Flex duct, 4-inch flex can only be used for 5 feet
Yeah.
maximum, so it almost has to always be solid pipe.
Oh, good. I think this was 6-inch, but I could be wrong. But whether it passes code or not, to me the big problem is this bathroom going to have moisture problems, especially in the wintertime? We're going to get condensation in there. Yeah. Will there be mold, mildew, moisture problems because of that, Steve?
And with all that static pressure, it's also really noisy, and they'll never turn it on.
Yeah. So let's talk about ventilation and Energy Star. There are 2 different categories of ventilation that is required for Energy Star. One of them is whole home ventilation, and the other one is kitchen ventilation. I have spent ridiculous amounts of time trying to explain this to people. And I think I ended up confusing them more than anything else. Am I the only one that does that? Chris just chuckled, so maybe I'm not the only one. Okay. Kitchen ventilation. I'll just tell you my ideal way that these things happen, or I think, and then if people want to ask questions, great. The Energy Star says that there needs to be kitchen ventilation, and needs to be at least 100 CFM, and the ventilation needs to come from within the kitchen. I think the best way to do that, now that's kind of all it says. How you want to accomplish that is largely up to you. I believe there are 3 main ways that people go about that. One, if you've got a vent hood, duct it to the outside. Oftentimes they are anyway. Sometimes they're not. But if you've got range hoods, duct them to the outside. Make sure it's 100 CFM, and you're good to go. If vent hoods are not going into those kitchens, then you can accomplish that with the fan on a microwave. Some microwaves you can just run the fan on it and you duct it to the outside. That can also accomplish that requirement. I think it's less functional and maybe doesn't help the overall intent nearly as well. The third way you can do it is you can just install a standalone ventilation fan in your kitchen. I think it's probably the most economical, maybe not. And it just needs to be in the kitchen. And so some people will install what's a typical fan you'd find in a bathroom in their kitchen. And obviously it can't be too close to the range, or it would need to be grease rated. No one wants to do that. So it's got to be, typically if it's 5 feet above the range, it needs to be 5 feet away from it as well. But refer to your local code inspector for that. And you just have it switched, and you just turn it on when you want, and vent odors from the kitchen. So that's that requirement. The other requirement is whole home ventilation. And I'll just tell you the way I like to accomplish it and kind of what the requirement is. there is something called ASHRAE 62.2, and all that states is it's just a formula for how much air needs to be exhausted from a building over a given time period. And it's a function of the square footage of the home and the number of bedrooms in the home. And sadly enough, I think I've got it memorized now. You guys probably do too. It's 1% of the square footage, or 1 CFM for every 100 square feet. Yeah, that's right. 1 CFM for every 100 square feet of floor space, and 7.5 CFM for every bedroom plus 1. So if you have a 1,000 square foot home, you need 10 CFM for that 1,000 square feet. Let's say it's 2 bedrooms, and then you would need 7.5 CFM plus 1 for those 2 bedrooms. So 7.5 times 3 is 22.5 plus the 10 for the square footage, 33.5 CFM being exhausted from that home continuously. So what you do is you buy a fan that is set up to run basically it's a fan that's got smarts in it. You run a constant hot to it so that even when it's switched off, it's got power. And then you just have little dip switches in it, or a little dial up inside of it. They're not really user serviceable. And you set it to run at 33.5 CFM. And it just runs there constantly, day in, day out. At that low setting, it should be near silent, if not silent, if you bought a half-decent fan. And that fulfills this requirement. Now, when someone goes into the bathroom to take a shower, they turn the switch on, and that fan will ramp up to 80 or 100 CFM, whatever it's rated at. So it's a 2-speed fan. And that fulfills the whole home requirement. I will say there are other ways of going about it, but every time I talk about it, it seems to confuse more than it clarifies. So, any questions about that? I'm happy to answer those. Okay. Yeah, Kevin.
Do you want to talk quickly about ERVs at all, or does it get too confusing?
Well, so, sure. I thought I'd keep that kind of high level because, again, this does confuse people. So the type of ventilation I've just been talking about, generally speaking, is referred to as exhaust only. Because all we are doing is we are taking air and we are pulling it out of the house. That's it. Now, whenever you mechanically pull air out of a home, to keep the home from collapsing on itself and the people from suffocating inside, that air has to be made up somehow, somewhere. And that just happens from one of the 5,000 tiny little leaks in every home has. That's why you can run that fan constantly, and the house doesn't go under, doesn't collapse because it became a vacuum, right? So that's called exhaust only. And in my, not just my humble opinion, building science would tell you that exhaust only is a good way to go in cold climates. So that's a good way to go in Utah for a low-cost way of doing things. It's not without challenges. If you want to, I'll say, step up to what is overall referred to as balanced ventilation, then there are smarter and more expensive ways of ventilating your home. And what it is it's a system that not only removes inside air from outside the house, it brings in ducted air from the outside into your house. Well, you can think that in January that would be bad to be bringing in that cold air, but what these systems do is they take some of the heat from the air that's being exhausted out of the house, and they give that heat to the air that's coming into the house through a heat exchanger. And those heat exchangers are anywhere from, they're typically 60 to maybe 80% efficient. So they're not perfect, but you know, in exhaust only, you're bringing in unconditioned air into your house, so it's a lot less of a penalty. Plus, you know exactly where your air is coming in. You're not putting your house under a little bit of negative pressure to make up that air. I think it's definitely the best way to go. If you're in a high performance homes, especially you want a really tight home, you definitely want balanced ventilation. But it's just like everything else. It costs a lot more than exhaust only ventilation. Now, in the old days, 10, 15 years ago, it would be several $1,000s for one of these systems. The prices have come way down. You can, entry level might be $500 for one, but that's also more expensive to install one of those than just an exhaust fan. So prices are coming down. It's definitely, in my opinion, not just my opinion, it's the best way to go. But like everything else, there's a cost associated with it. You guys see any in the homes you're doing? Any balanced? Some? Yeah. Most? Wow. Okay. That's cool. Yeah, balance is a great way to go. And when you duct them, do not duct them like this bath fan is. 'Cause, boy, let me just talk about grade 1 installation. We've actually covered a lot of this already. Grade 1 installation. Energy Star definitely cares about the R value of the insulation you're using. But just as much as that, it cares about the way the insulation is installed. And the way that's recorded is there's grade 1, 2, and 3. And grade 1 is real nice, beautiful installation. Grade 2 is okay, grade 3 is terrible. And by terrible, think of an oddly shaped stud cavity, whether it's got J boxes in it or it's not 16 and a half, or excuse me, the nominal width. And rather than cutting the bat to fit, they just shove it in. And when you do that, in some places it's going to be compacted too much. Other places it's going to be nothing there. And the way that's usually referred to in HERS Radar world is gaps, voids, and compressions. And all of those things reduce the functional R value of an install. Typically, in residential new construction, bats are never installed to a grade 1. It's far more time consuming to do it that way than it is a grade 2 or a grade 3. It's really difficult. If you want to build Energy Star and you want your life to be good, blow in your insulation. You do get higher R values as well. The standard density bats for a 2x6 stud cavity are R19. You can get high density bats that are R21. Last I've heard, the R21 bat install is now costing more than the blown in. So I don't know why you would ever do them. It costs more and doesn't do as good a job. What I like to see in 2x6 walls is a fiberglass blown in, and that achieves about R23. Some will claim R24, but we're right in that area. So the R value is higher, which is great, but even better, I should have included a picture. Dang it. The install is just fantastic. It fills all the little nooks and crannies, and it's just far more consistent and functions better. I don't know if y'all have any thoughts on this. Brandon, you guys know Brandon, our field supervisor? You know, he's done 4 gazillion blower door tests in his life. And his take on it, and this is all anecdotal, we haven't done any data crunching on this. There's no hard analysis, but he feels like, all things considered equal, a blown install gives you almost 1 ACH advantage over a bat install in homes. They're just a little more airtight. The density's higher. It's more uniform. Just a better way to go. Air sealing, I feel like there's kind of two ways to go on that. You can go after it with foam and caulk, and if you've got good guys and your home's been framed well, you can get a tight home. But you've got to have good guys. They've got to know what they're doing, and they've got to care at least a little bit. It's not always the case, especially with air sealing. And you can get a tight home. But you can also use a product called AeroSeal. It's not cheap, but it is relatively hassle-free. It has to happen at the right time of the house. Did I say seal? Aero barrier. AeroSeal is for sealing duct systems. Aero barrier is for sealing homes. Aero barrier, an aerosol is sprayed into the house under pressure, and it will go find all the little holes and plug them up. It's the more expensive way to go, but also they're able to functionally test how tight the home is while they're doing it, so you have a pretty good idea of where the home's going to be. I think if you want to get much below 3 air changes per hour, you kind of have to start using that if you want to do really tight homes, like 1 air change per hour. You probably have to do that. I don't know that you can get down to 1 with just great stuff and caulk. We end at 1:30?
Technically, I think that's what one of the invites said.
Oh, okay. I just want to. So, you're a builder and you want to build Energy Star. How many of the HERS raters in this room have received a phone call from someone who said, I want to certify, can you certify my home as Energy Star? Yeah, of course we can. And they say, well, where are you at in the construction process? We just got C of O last Friday. C of O is certificate of occupancy. That means the home is done. Okay. That is not the time to call your HERS rater. So when is the time to call your HERS rater? Plan stage. So when you've got plans and you've spec'd things out, especially with version 3.2, we've got to model that thing as designed and see where it comes in. Because business as usual does not pass Energy Star 3.2 anymore. So you want to include us in the planning stage. If also do not hold any value engineering meetings without us. Okay. It's amazing how we get in trouble. They say, well, you told us it was going to pass. We're like, well, you changed all these things without telling us. So, and then we need to be there to see the all the insulation installs, and look at air barriers, flashings, all the stuff that are on our checklists. And then we come in at final. So we do the duct. We like to do our duct testing at 4-way typically. You don't have to, but that's where we like to do it. And then we come in and do a blower door tested final. And then once that's gathering all the field data, and then the rest of it's the software work that Chris loves so much. Anything else from the peanut gallery up here? Okay. Plan stage is the best time. Okay. What? I just had to. Yeah. No carpet within 2.5 feet of a toilet, okay? Like you're too young. I was alive when people used to do that. Again, as I mentioned earlier, the number one killer of homes is bulk water intrusion. So Energy Star has their water management checklist that helps you do your flashings correctly and your site grading, your roof assembly, building materials. and no carpet in the bathroom. Okay. Any questions on that? Okay, so I used to have this slide might be kind of dumb at this point because it used to just say duct leakage and correct wiring for ventilation. That was in like previous versions of Energy Star, because those are the things that were like big gotchas, you know. If your ducts are too leaky, you got to get those fixed. If you've sheetrocked your home and you didn't run the correct wiring or ducting for your ventilation, you're hosed, you know. But man, with version 3.2, I kind of just kept thinking I could just keep extending this list out to just be like all the other lists we've been looking at today. And I'll just say you're never going to accidentally certify a home to Energy Star version 3.2. You've got to be deliberate in your insulation, your cladding, your framing, your air sealing. You've got to partner with a great HVAC contractor who cares and is willing to learn and is willing to maybe do things differently than they've done in the past. And you've got to be willing to use better efficiency and good quality mechanical equipment, ventilation fans. I feel like this list could go on. And so, again, this slide may have been a little dumb because it just kept growing as I thought about it. All right. So this is, first of all, don't take a picture of this and say, Troy said if you do these things, you're going to pass Energy Star 3.2, because it's just not true. What I'm saying is we have been able to get homes with this spec to pass Energy Star 3.2. And not all of them, but sometimes. Part of it, I put the picture in because that's like Utah mountains. So this is like Utah Wasatch Front, right? So 2x6 framing with R23 blown in. We've been able to get them to pass without having to do R5 rigid exterior. I feel like that might be a non-starter for a lot of people. Can you do it with R19 bats? I doubt it. I don't think you could. So you got to be blowing in the higher stuff. 95% AFUE furnace or better. 95 is pretty dang high. You know, going from 95 to 96 or 97's probably not going to like change anything dramatically, but you can't really go below 95 and have a chance to pass. I didn't put in heat pump HSPF numbers for this, just because, especially this has been geared more towards single family. There's actually a different version of Energy Star for multifamily that we haven't really talked about today for the exciting sequel. And heat pumps are far more common in multifamily than single family at this point. So I didn't put a heat pump efficiency in. 14 SEER AC or better. Again, that's federal minimum right now. So nothing heroic about your AC efficiency. It's about the only thing that's not heroic. Tankless hot water heater. You might be able to get them to go with like a 2-pipe storage tank, but tankless is better. And so if electric, has to be like a good heat pump hot water heater, not just a heat pump, but like, because there is a little bit of a range in the heat pump world. It's got to be like the top end. So again, electric is not necessarily better in this case. 2 to 3 air changes per hour. If you're above 3, you're starting to really hurt yourself with that. So you've got it. Tighter's better. So I didn't say 1 to 3 because we don't see many houses go below 2. Do you see one below 2? Yeah, round, yeah. Um, so I said efficient kitchen and whole home ventilation fans. Some of the data that you put into the software isn't just that it's an ASHRAE 62.2 compliant fan, but it asks you how many watts does it use for how much air does it move. And you can imagine that if you've got a fan that's running 24/7 indefinitely to vent it out, that it needs to be efficient. Otherwise, it can hurt you. So you've got to have efficient ventilation fans. Okay, the HVAC system needs to be properly installed by a credentialed HVAC contractor. There's a certification process that contractors need to go through if they want to work on Energy Star homes. Are we ending in 1 minute, or do you want to go longer? Sure, show, Kev.
If we go longer, but
I'll wrap it up. I think this might be the last slide. Yeah, pretty darn close. Okay, the last relevant slide. They need to be credentialed, which means they've taken some tests and watched some programs to make sure they're good. They understand the requirements for Energy Star, and it's not cheap. They have to pay to get credentialed, and they have to pay every year to get re-upped. And that used to be an absolute requirement. Every home had to have the HVAC system installed by a credentialed HVAC installer. There's actually another way of doing it now. So if you have someone that's not credentialed do it, you can still pass, but then the HVAC system needs to be graded by a HERS rater. Are you guys doing any grading yet? Are you grading systems yet? Okay, so that's kind of a newer option. The good news is we're all being trained in 2 weeks how to do it. Thanks, Kevin. And also having your system graded actually allows, the software likes it more than just having a credentialed installer. So it's another opportunity to gain some points. But it's pretty new. The industry here in Utah is right now just being trained up on how to do it. It also, we're just getting up to speed on it as well. It's time consuming. It's tough. So we're figuring it all out, but that'll be another option. So bottom line is you've got to have your HVAC system top notch, functioning correctly, designed correctly, installed correctly, and it has to be a good system. Windows with a U factor of 0.27. Again, some of our builders are finding 0.25 windows that are pretty cheap. So if you can find those, use them. But yeah, we're getting them to pass with 0.27. And as I mentioned earlier, one builder that we were doing a bunch of modeling for, we could not get any of their slab on grade plans to pass. So with specs roughly like this. So if you want slab on grade version 3.2, you'll need to do some extra stuff to get them to pass. So so it's definitely possible, and I think cost effectively possible to do this within the way of we typically build here in Utah. But you can't really skimp on anything, I don't think. I mean, some people love to build a good wall but don't care about water heaters. You've got to do all of it really well to pass 3.2. But there are, the tax credit. I think if you're close to this, plenty of the builders that we worked with, have been relatively close to this, just the way they've been building for a couple of years now. So it wasn't a big jump for them to go to 3.2. Other builders we've worked with, it's been a larger leap, and so some just decided they're not going to do it. So it kind of depends on where you're at, what's that?
rebates aren't too bad.
The rebates aren't bad. The tax credits are good, and I do think that an Energy Star, especially version 3.2 home, it's a good house. If everything's been done the way it's supposed to, it's an efficient home that is functioning the way it's supposed to, and it's going to be comfortable and durable and reasonably low cost to operate, especially relative to others. Yes.
Okay, I have a question about wood studs acting as a thermal bridge. How do metal studs over there work?
Well, if wood studs are this bad, metal studs are this bad. Okay. Metal studs, well, luckily, I've never seen a metal stud in residential, like single family home construction. They're too expensive. But they would be like 100 times worse. I've seen photos of not just cold spots from studs, but actually like frost on the inside of walls adjacent to a metal stud. Whenever metal studs are used in commercial construction, there's always continuous insulation on the outside of it. It has to be. It'd be a nightmare otherwise. So, yeah, good question though. Okay. This might be a little outdated. It really is. We've already hit all this. You've got to use you can't pass without sealed combustion. Range hoods, I think, is the best way to vent kitchens. And maybe the best way to make your life good is partnering with an HVAC contractor. Yeah, if they roll their eyes just once at anything you tell them, don't walk away from them, run. Because they've got to believe in this stuff as well, or you just won't. It'll be really hard. It'll be really hard. So you've got to partner with a good one, even just one that's willing to learn. Whew. There we go. So I will reiterate. So I'm the company called Building Science West, but there are 2 other rating organizations in this room, 3 other raters. You guys don't really work as a rater, do you?
Do a rating and help pass it on to the rating.
Okay. But there are a number of qualified HERS raters. In fact, I like the 3 of us that we have in the room here, because we've got Chris down in Orem, Steve up in Ogden, and we're kind of here. But I think we all overlap geographically, which is fine. But both of these guys are experienced and fantastic. So if you want to jump into Energy Star Homes, you've got, I think, several really good choices for partnering with a HERS rater along the Wasatch Front and in St. George too. So there we go. Any questions?
I actually have.
Sweet.
So when you blow in insulation inside of walls using the drape system, are you ending up with more mass in the walls as far as insulation goes?
I think
Versus back, R19 back versus blowing, are you getting more mass?
Yeah, definitely. There's definitely more mass. The density is definitely higher. I mean, it's still fiberglass, but there's definitely more of it.
Why couldn't you put more back?
That's a great. Well, because there is think of it as a bell curve. There's an optimum density, and if you tried to put 2 bats in, because there is a high density bat that's R21, so it gets you more. They also cost twice as much as the R19s, but yeah, there's an optimal density, and the contractors try to hit that when they're blowing it in. The great benefit is the uniformity of the install and the additional density. Those 2 together make it just a much nicer product. So, okay. Thanks, everyone. Have a great night. Yeah.